Okay, hello, 7th graders. Here is the way we work some of these problems for the Chapter 8 review. It says an airplane traveling at an altitude of 24,000 feet is told by air traffic control to climb to 30,000 feet. So right away, we know that that airplane is going to be 24,000 feet up, and it's going to climb and get up to 30,000 feet. Okay? The airplane climbs at 1,200 or 1,200 feet per minute. How many minutes will it take for the airplane to reach 30,000 feet? Well, how many minutes? Let's see. So we know that if I draw a triangle like this, there's going to be a difference right here of a little more. It's going to be about 5,000 feet. Is that right? Oh, 6,000, because it's 24,000 and 30,000, and that difference is 6,000 feet. So we know we have to climb 6,000 feet. Okay, so that's a distance. 6,000 feet. We know we have a rate of 1,200 feet per minute. How many minutes will it take for the airplane to reach 30,000 feet? Well, we know that the 24,000 and 30,000, that difference is 6,000, so I have to find the rate time. I can use rate times time equals distance. Okay? My rate is 1,200 feet per minute. The time, I don't know the time, so I'm going to put T there. And I know my distance is 6,000. So I'm simply going to do a division, okay, of both sides by 1,200. Okay, and that, how many minutes will that be? On clear. Well, that one isn't working. Let's try a different calculator. I'll use the one on my phone. Well, wait, I can do it without a calculator. If I divide, I can get rid of those zeros, get rid of those zeros. That's dividing by 10 and by 100 then. 60 divided by 12 is 5. The answer is 5 minutes. There you go, 5 minutes. That's what the solution is. Okay, does that make sense? It takes 5 minutes to go from 24,000 feet up to 30,000 feet. I think that makes pretty good sense. I'll leave it at that. All right, let's solve these. We have 5k minus 8. We know we look for like terms to try to help simplify. Well, I have a 5k and a negative k. That's going to give me 4k, and I'll still have my minus 8 equals 48. If I subtract 8 from each side, I won't do that from each side, but I'll add 8 instead of subtracting, because that's already subtraction. I want to get the k terms, or the variable terms, on one side of the equation and numbers on the other, and this will help me do that. I now have 4k remaining equals, that's going to be 56. Let's see, if I divide both sides by 4, that becomes 1k equals 56 divided by 4. Let's see, 4 times 12, is that 16? Does 4 go in there once? Well, yeah, that's 16. Good deal. There's number 2, part A. How about number 2, part B? Let's look at that. Well, I have the same kind of an idea here. I want to get the whole number terms on one side and the variables on the other. And I think I have this already taken care of. I'm going to rewrite this as 8. So I have 9a plus 26 equals 8. There's no terms that I can add together on each side. They're in simplest form on each side. So my next step would be to subtract 26. So I get 9a, this becomes my 0 pair, equals, what's 8 minus 26? Let's see, larger, that's 26, minus smaller, that's 8. So I'm thinking 26 minus 8 is going to be 18, but the larger number is negative, so that's negative 18. Oh, that'll divide quite nicely. I see that I can go ahead and divide by 9 on each side to get rid of the 1 here. That's 1. A equals negative 2. That's an A, not a 9. A. A equals negative 2. All right, let's go on to letter C. Ooh, I have all the variables on this side, so I might as well leave them there. I see I can add a couple variables together. That's a subtraction symbol, but that means adding a negative. So I have 31 equals 3m minus m would be 2m plus 7. To get the m term by itself, I'm going to go ahead and let's subtract 7 from each side. So this becomes a 0 pair. 2m equals, what's 31 minus 7? Let's see. I think that's 20. 24, 6. I think it's 20, no. 4. Looks like 24. It's going to be a positive 24, though, not negative. And this is an equal sign, not a negative sign. Sorry about that. Now I'm going to divide by 2 here. Divide by 2 there. I can do that to get rid of this 2 in front of the m. That's my giant 1. This will be 12. M equals 12. There's your solution. Okay? That's number 1 and 2. Let's do number 3. Create 2 versions of a question about a food served at your school. Write one question that is biased and the other which is not. Explain why the first version is a biased question. Well, I think the first one I'm going to write is a biased question. It can easily be this. I think the food in the cafeteria is awful. Don't you? That is certainly a biased question. It's biased because I'm trying to sway the person interviewed. Okay? Ooh, right there. That's the bias question. Here's the less biased, or hopefully not even biased at all. How do you think the food tastes in the cafeteria? I'm interjecting my own, I'm not interjecting anything. I'm simply asking the question, okay? I'm simply asking a question. How do you think it tastes? That's it. All right, let's look at number 4. Number 4 asks, draw a quadrilateral with at least one right angle. Is there more than one way to do this? That is, can you make different looking quadrilaterals that have at least one right angle? If so, draw different quadrilaterals and label each one with its name, rectangle, square, etc. If not, explain why not. Well, here we go. Well, if I have one right angle, I know I can have one right angle right here. And here is a kind of quadrilateral. Okay, that's one. That's called a trapezoid. Another kind I could draw would be, let's see, something like this. That's a trapezoid too, but it's more like a kite. Okay? This is my right angle. Then, of course, I have the usual, I have a square with at least one right angle. I have a rectangle with at least one right angle. I'm thinking that's just about it. Okay? That's the first part, part A. Okay? If we're going to move on to part B, I think, asks it a little differently. Draw a quadrilateral with only one right angle. Only one right angle. Only one right angle. Draw a quadrilateral. Well, I know I can do what I did first a little bit ago. I have this. There's my quadrilateral with only one right angle. Is there more than one way to do that? If so, draw the different quadrilaterals and label each one. Well, here's one. This is number 1. And I think that kite thing that I drew before would probably work pretty good. Okay, here's a right angle there. Okay. And then I think that's probably about it. Okay. Okay. Is there more than one way to do this? Okay, I think that's it. Part C, draw a quadrilateral with exactly... Well, I did that again. There it is. Part C. Here, this is the quadrilateral here, quadrilateral there. I think that's about it for your right angles. For one right angle. Only one right angle. Okay? Letter C, draw a quadrilateral with exactly 2 right angles. Exactly 2 right angles. So, let's see. I have one right angle here, one right angle here. I guess I can do this. That's a trapezoid. I think that's it. That's a trapezoid. About all I can make is trapezoids. Label each one with its name. Here's a trapezoid. If not, explain why not. I think that's it. Only one, a trapezoid. Now, there's different versions of trapezoids, you know. They can be turned, etc., but just a trapezoid. Now draw a quadrilateral with exactly 3 right angles. I think it's impossible. Okay? 1, 2. Well, the third one would be here. 1, 2, 3, but that line extends and this line extends. That makes another right angle. So nope. Not possible. Okay? Not possible. Well, we know, although we didn't study this, that it's 360 degrees on all the angles on interior angles of a rectangle, of a quadrilateral. So they have to all add up to 360. If you have a 90 and a 90 and 90, that's 270. The last one has to add up to 90. So that is a right angle. So sorry, you can't draw a quadrilateral with exactly 3 right angles. Not possible. Okay, let's go to number 5. Number 5 asks, write an equation that would enable you to solve the problem. Marta's jump rope is 25 inches shorter than 1.5 times the length of Dilbert's rope. Okay, here's Marta. Her rope is, let's do R for rope. R for rope. Marta, her rope is 25 inches shorter than 1.5 times the length of Dilbert's. Well, 1.5 times the length of Dilbert's rope. Okay. We know Dilbert's rope is what? Dilbert's rope is just R. That's what it is. So then, total, it says laid end to end, they measure 221 inches. Well, that means we know but Dilbert's, which is R for rope, plus Marta's, which is 1.5 R for rope, minus 25, so this is Dilbert's right here, and Marta, that's there. Altogether, that's 221 inches long. So if it's 221 inches long, let's see, how do I simplify this? Well, I think we just take the R, these 2 R terms, this is really 1, so it really comes out to 2.5 R. 1 R plus 1.5 R. And then minus 25 equals 221. So if I add 25 to each side, okay, that means this one This I'm going to add 25, add 25. I get 2.5R equals, that's going to be 246. So 246 divided by 2.5. Okay? So I'm going to use my calculator and my handy dandy calculator that I have over here on the side, which you can't see, but I'll put it here. There we go. I'm going to have 246 divided by 2.5 equals 98.4. 98.4. Okay? 98.4. There you go. That's it. Number 6. Let's go on here. What value of x is a solution to this equation? Represented below. Well, the value, I have to find what these values are to make them 7 plus these two x's equals 65. Well, right there's the equation. I'm going to go ahead and solve it. 2x plus 7 equals 65. I'm going to go ahead and subtract 7 from each side. That allows me to have 2x equals, what's 65 minus that? That's 58, if I'm not mistaken. Right? 2x 65 minus 7 is 50, yeah, 58. So I'm going to divide both sides by 2. X equals whatever 58 is divided in 2. I think that's 29. 29 sounds like a very reasonable answer. Okay? There you go. That works for me. 29, and that is true. 29 right there. Number 6. Number 7. Let's look at number 7 now. Number 7 is right here. Number 7, we're going to have some solving again and checking the solution. I'm going to subtract 38 from each side. Okay, that way I get 6w equals 41 minus 38 is 3. If I divide by 6, I do that there. X equals 1/2. Does 1/2 really work? Let's check. If I put 1/2 in the original equation, which is that right there, 6 times 1/2 for w plus 38 equals 41. Well, what's 1/2 times 6? 1/2 times 6 is 3. 3 plus 38 equals 41. Yep, that's true. Very good. Next, I have a t here. I want to solve for t, so I'm going to subtract 8 from each side. Okay. That gives me 3 on the right side and 4t on the left. 4t equals 3. I have to divide by something to get t by itself. I'm going to divide by 4. That means t equals 3/4. So if I put that into the original equation, 4 times 3/4 plus 8 equals 11. Let's make sure. Well, let's see. When I multiply these, that will give me 12 over 4. 12 over 4 is just like saying, hey, there's my 1 right there, giant 1. Cancel that out. That's 3 plus 8 equals 11. Is that right? Yeah. 3 plus 8 is true. This one might be a little trickier. It's got some negative signs, so we have to be really careful. We have 9k right here. We want to solve for 9k. I'm going to start by adding 7 to each side. Adding 7. When I add 7, this becomes a 0 pair. This becomes negative 4 plus 7. It's 3. That equals 9k. I need to get the k by itself, and I have a coefficient of 9. That means I divide by 9 on both sides. Dividing by 9, that's going to be 1/3. So 1/3 equals k. Checking the answer, because that's what it says. Check your solution. That's part of the expectation when you take your assessment. Let's see, 1/3 equals k. So we got to put that in. Negative 4 equals 9 times 1/3 minus 7. This is negative 4 equals, what is this going to be? What's 1/3 of 9? Or, if I cancel a little bit right here, this is in the denominator, that's in the numerator. I can interchange them, so it really is 9 over 3. Well, that 9 over 3 is really 3. Negative 4 equals 3 minus 7. Let's see, negative 4 equals 3 minus... Yeah, negative 4 works perfectly. Okay. Let's go to number 8. Number 8. Of course, you can always rewind if you need to. Which triangle appears to be a right angle? Well, I don't see anything that looks like a 90-degree angle here. This one's close, but I think number 3 is the only one. Okay, for number 8, I'd say number 3 is the only one. Letter B, which of the triangles is called an obtuse triangle? Which one do you think that is and why? Well, I think this is an obtuse triangle right here, simply because we have one obtuse angle. Number 4 has an obtuse angle. Okay? That's why it's called an obtuse. Okay? That's why it's called an obtuse triangle. Letter C. One of the triangles in the equilateral triangle is an equilateral triangles. One of the triangles is an equilateral triangle. Isn't that something? We don't need that on there. Which means all the sides are the same length. Which triangle was that one? Well, I can tell these are close, but they're not quite the same length. I'd have to say triangle 1. Number 1. That's it, just number 1. That's the answer. Let's go on to number 9. Classify each angle as right, obtuse, or acute. Then estimate the measure of each angle in degrees. Well, this is definitely acute, okay? This is definitely acute. So you need to write that down. And then the acute angle, we're going to go right here. Well, I know if I have an exact measurement there, it's going to be a little bit more than 45. 45 would be about right there, exactly in the middle between this line and that line, that ray. Those are rays, actually. Okay, so I'd say probably like 51 degrees. Okay? The actual answer that the text says is 50 degrees. So there you go. There's my estimate. That's the actual. All right? They're pretty close. Letter B, this is certainly an obtuse angle. Okay? Obtuse angle, because the rays definitely open up farther. This is our initial ray, the one we start with, and we move over to there. That's called the terminal ray. Initial, terminal. So let's see. I know that a right angle would give me about right there, and a straight angle would be right here. It looks like it's almost directly between these two angles. These two lines here, almost directly. Maybe not quite as much. So a little shorter maybe. So I'd say it's a little shorter than a 135, which is 90 plus 45. So I'm going to say 130 degrees, which that's what the text says, 130 degrees. We're estimating now. Well, this one is a right angle, okay? And that is 90 degrees on the dot. It has to be. So there's your solution, exactly 90 degrees. And you might want to be a little clearer, so exactly 90 degrees. Okay, let's go on to 10. Number 10. Number 10. This is kind of long, but suppose you want to join the team of the basketball teams. If you use the mean scores for each team, which team would join and why? Holy cow, well, how would you... Their scores. This is how many they scored each game. If you use the mean scores for each team, which team would you join and why? Well, let's see. The mean of these, of the Wildcats, let's go Wildcats. Let's say the mean. I have to add some numbers together and divide by 5. So let's add them together. Okay? If I do that, of course, we're going to have 67 plus 87 plus 54 plus 99 plus 78 divided by 5. When I do that, let's see, I add those together. The Wildcats' mean is 77. Okay? I'm going to divide by 5 here. When I find the mean for the Bruins, 1, 2, 3, 4, 5. Divide by 5 again. Okay? That is the mean equals 69. Okay? That's the mean. And then the last one, let's see, Panthers. Their mean is Panthers. We call these Bruins. Bruins. I divide by 5 again. The Panthers, add those together, divide by 5. That's going to be 68.2. So which team would I want to join? I'd want to join the Wildcats. Wildcats. Their mean is highest. When you have a high mean, you're likely going to win a couple games. Okay? Derby says don't use the mean, use the median score to decide. Derby adds, why would Derby suggest this? Why would Derby suggest this? Well, when you look at the medians, you're going to list all of them in order, of course. Okay? List those numbers in order. I'm sorry, I thought I was on the screen, but I'm not. It's hard to tell. Let's back up. These numbers right here, added together, divide by 5, is 77. The Bruins, add these 5 numbers together, get the mean of 69, because you divide by 5. 32, 101, 65, 88, 55. Their mean is 68.2. So which team would you rather pay for? Just use their highest mean. And then Derby says don't use the mean score, use the median score to decide. Derby adds, why would Derby suggest this? If you use the median score, which team would you join and why? Well, let's see. The median, when I look at the median, the Wildcats, you know, I list all those together. Okay, I find out what their median. Wildcats, the median is 78. Okay, the Bruins, the median is 80. And the Panthers, the median is 65. Derby might think the median is a better representation since half the games were higher than the median and half were lower. Deciding based on this would mean going with the Bruins. We would go with the Bruins if you decide to do this. Half of the scores are above, half are below. There you go. Letter C. In this article, you are going to write an article for each team or for the local paper. Of course, you want each school to look its best. What would you say in each article to highlight the team's strengths? Okay? Well, when you look at the scores, okay, first of all, we would say in Article 1, you would talk about Wildcats' highest average. In Article 2, you'd say talk about the Bruins. They have the highest mean, and that's what you talk about. Okay? And you could write some more. In Article 3, okay, you would mention somewhere that the Panthers have the highest scoring game of 101 points. Okay? That's what you'd say. Okay? When I look at this, that's 101 points up there. Wow, that's really impressive. 88, that's the other impressive number. I mean, they really scored a lot of points. Okay? All right, number 11 says make a stem and leaf plot of Sally's scores for each quarter. Stem and leaf plot. Well, let's go to quarter number 1. Okay, quarter 1. I'd make a stem and leaf plot. I'm going to do the best I can by eyeballing it here. I didn't really do the problem, but let's call this the tens, and this is the ones. So the tens, let's see. My highest is a 9, 95. My lowest is in a 7, 70. So I'm going to start with sevens. 7, we know there's a 70. There's a 71. There's a 73. Okay, let's do my 80s. My 80s, there's an 80. There's an 82 and an 85. In my 90s, there is a 92 and a 95. There you go. I just made a stem and leaf plot for quarter number 1. For quarter number 2, I know that I have scores in the 70s, 80s, 90s, and I even have a 100. So my 10s would be, here's my next group. My 10s would be 7s, 8s, 9s, and 10. That represents the hundreds. If I have 10 10s, that's 100. Here's 1s. When I look for the smallest one, for the 70s, I see only one number that's a 70. That's a 73. Do I see any 8s, 80s? Yeah, here's an 85, 85, and 86. So I have an 85, 85, and 86. And an 87. How about in the 90s? Yes, I have a 91, and I have a 96. And in the 100s, I have one of them. Find the mean and median for Sally's first and second grades. Well, the median would be 1, 2, 3, 4, 5, 6, 7, 8. I have 8 scores. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 scores. So I count 4 from the bottom. 1, 2, 3, 4. Underline it. 4 from the top. 1, 2, 3, 4. So the average between the 80 and the 82 would be the median. Okay? Find the mean and median. You may have to use some more paper somewhere else. I'll just do the medians up here. Median of quarter 1 is the average between 80 and 82. That's going to be 81. The median for quarter 2, let's count up. 1, 2, 3, 4. 1, 2, 3, 4. So it's between 86 and 87. We find our average. That's going to be 86.5, 86 and a half. That's the median. Finding the mean, I add them all together and divide by how many numbers there are. Don't forget when you're adding, it's not 0 plus 1 plus 3. It's 70 plus 71 plus 73, etc. You add those together, and you should come up with the mean for quarter 1. Let's see. The mean for quarter 1 should be 87 point. Wait, that's the quarter. Second quarter. Median 81. Second quarter mean. The first quarter mean is 81. And the median was 81. How about that? Same exact. The mean for quarter 2 is going to be 87.88. Okay? You're adding all them together, dividing by how many there are, which is 8. Which quarter did Sally do better? Let's see. Well, in quarter 2, she had a higher average. The means are exactly the same. First quarter, no. Average. Well, let's see. The mean in quarter 1 and the mean in quarter 2 are different. Quarter 2, she had a better mean. And the median, she had, quarter 1, quarter 2, mean. Median, quarter 1, quarter 2. It certainly appears like second quarter. Second quarter, Sally did better. She had a higher average and higher median of scores. Okay? There you go. That's number 11. Let's go on to number 12. Number 12. Oh boy, that's big. She started with the ugliest equation she had ever seen. What can we do to get that all straightened out? Well, first, I would collect all the terms that have x in them together and write them as 12x minus 8x plus 4x minus 3x. Then I'd get all the whole numbers. There's a 9 plus 10 plus 7 equals. I'll do the same thing on this side. Let's collect the x terms. I have negative 6x minus 9x, and I have a plus 8x. Then I'm going to collect the whole numbers. Subtract 2, subtract 7, add 11, and add 4. Well, let's look at them. 12x minus 8x is 4x, plus another 4x is 8x, minus 3x. Looks like that's a 5x. Add the whole numbers. 10 and 7 is 17, plus 9 more is 26. 5x plus 26 equals. Here are the x terms, negative 6, negative 9. That makes negative 15. Negative 15 plus 8 is negative 7x. Then I'm going to add these numbers together. I have a negative 2, negative 7. That makes negative 9. Negative 9 plus 11 is 2, plus 4 is 6. At least that's what I've got. Let's see if I can do it right. Okay? So it looks like that, oh, when she was finished, she determined x equals 3. Is she correct? How do you know? Well, let's see. Let's find out. If I subtract 25 from each side, I'm going to get 5x equals negative 7x. That's going to be negative 19. Then I'm going to add 7x to each side. That gives me 12x equals negative 19. I don't think I'm going to get a 3 out of that. Is 3. Is she correct? I'm going to say not correct. How do you know? Because 3 does not fit the equation and make it true. Okay? We could also do this. I could take 3 and substitute it in every place there's an x, and you could just do it numerically, solve numerically. But there's no way that's going to be equal. No way whatsoever. Okay? There you go. That's it. Okay. I may have made a mistake here. 9, 10, 7. That's going to be 26, by the way. 26. So that would be 22. No, it's still not going to work. This would be yeah, that's definitely not going to be, 3 doesn't work. Okay, one of the angles is an isosceles triangle is 46 degrees. What are the possible measures of the other angles? Okay, so an isosceles triangle, isosceles means what? It means none of the side lengths are the same. So we have one side, though, that is one angle that's 46 degrees. 46 degrees. Okay? So if it's 46 degrees, I have a number of different angles that would work here. Okay? So I would say angle X and angle Y. So any angle X and angle Y that add up to 134. How did I get that? Because I have 180, that's the interior angles of a triangle, that's the measurement of those interior angles. Subtract 46, that's 134. So I know 134, X and Y have to add up to 134. So these angles here and here can be just about anything you want it to be, and the side lengths can be anything you want it to be as long as it's 46 degrees. Okay, so the possible measurement of the other angles is There's a lot of them, but they have to add up to 134 degrees. Okay? All right. The measure of angle y is what? Well, I know I have 6x minus 25 degrees, and I have 4x plus 15 degrees. I'm going to zoom in a little bit. I think the first thing I notice is these are vertical angles. Therefore, they are equal. Vertical angles always have equal measurement. So if I go ahead and write an equation, I can write an equation that states these two that are equal to each other. So we get 6x minus 25 equals 4x plus 15. So those two are equal. Okay, well, let's do the work. I'm going to add 25 to each side. And I'm doing that so that I can get the constant terms on the right side. Here's my constant term. That's a 0 pair. So I get 6x equals 4x plus 40. Now I'm going to go ahead and subtract 4x from each side. I can do that as long as it's the same thing. That makes this a 0 pair, and I get 2x equals 40. Therefore, if I divide by 2, you see that x equals 20. Any questions about that? I hope there's none. But you can go back and look at it if you need. If x is 20, I can put it into one of these and figure out what this whole angle actually measures. I'm going to go ahead and put it right in there. Put 20 degrees in there. Well, 4 times 20 plus 15. 4 times 20 is what? That's 80 plus 15. That's 95 degrees. That means this side is 95. That means this side is 95 degrees. So if this is 95, how do I find y? 95. Well, I notice that this is a straight angle. This straight angle is 180 degrees. So if I have 180 degrees, okay, that should equal 95 plus whatever y is. Well, I'm going to subtract 95 from here, subtract 95 from here. Algebraically, I'm solving. That means y equals, yep, it's 85 degrees. Y equals 85 degrees. 85 degrees. So I guess that's part C. There you go. Part C. That's number 14. Let's go on to number 15. Draw an example of each of the following. I would like you to make sure you use a straight edge when you're doing an acute angle. Please use a straight edge. Possibly on your test I'll give you a straight edge of some kind, probably a protractor actually. An acute angle is less than 90 degrees. Does this look less than 90 degrees? Sure does. That's an acute angle. A right angle should be 90 degrees. Okay? 90 degrees. So it should be really perpendicular from each other. So that's pretty good. I'm going to go ahead and put a box right there. That's my 90-degree angle. An obtuse angle. Use a straight edge. I think you guys know those anyway. I shouldn't have to spend much time on this. I'm really sorry I was not focused on that for a second. I'll go back and review. Draw an acute angle. This is an acute angle. I'm using a straight edge. Less than 90 degrees. Right angle is 90 degrees. An obtuse angle is greater than 90 degrees. Okay? There you go. Number 16. I'll make sure we're in the box this time. There we are. It's a square. If the perimeter is 36 centimeters, what are the dimensions of the square? Explain how you know. Well, if I know that they're the same, I can call them x if I want to. Algebraically, I can say, hey, there's 4 sides because I add them all together. It's x plus x 4 times equals 36. It's a very straightforward process to solve x. Divide by 4, divide by 4. That's a 1. There's x equals 4. 4 goes into 36 how many times? 4. 9. 9 times. X equals 9. Okay? Explain how you know. Well, you can say all kinds of different things, but I can say because X must equal the same on each side. Perimeter equals 36. So divide by 4, and 9 is the length of each side. You can write a lot of different other things, but really that's really about all there is to it. Okay. All right, last one. I think, yeah, this is number 17. We have 2 of them. We have to find some angles. We know this is a straight angle. If this is a straight angle, zoom in a little bit more there. If this is a straight angle, come on. It's not focused very nice. Hold on. I'm just going to have to do that. Maybe that'll work. Nah. Why is that not focusing? There we go. All right, so this is A. We know this is 24 degrees. We know we have 180 is a straight angle. That equals 24 plus A. Whatever A is, those two should add up to 180. So I subtract 24 here and there. That gives me 156. That's the angle for A. Okay, for letter B, I'll slide up just a little bit. Letter B, we know this is X, that's Y. It feels like I did something similar to that before. Okay, I know this is 57. A vertical angle is always the same, so this is 57. I know this straight angle right here, straight angle, again, 180 degrees should equal 57 plus X. If I subtract 57, X equals 23 degrees, 123 degrees. There you go. I am finished with this review. Have a good one, everybody.